So we're going to start with exponentials today. And this is in Unit 5 that we skipped earlier. So just wanted to make sure we got this information in. This will be information that you will see on the EOC test. So it is something that's very important we pay attention to. Now, before we get started on this page, I want to go to page 45 in your packet. And page 45 is a review of parent functions. And parent functions talk about all the different ones. Here's the parent function for a linear. Here's a quadratic. We're quite familiar with that now that we've finished the quadratic unit. Here is a cubic. Haven't seen it a lot. Absolute value we've dealt with. Square root, we haven't really dealt with much. But today, we're going to look at exponentials. And I just want to refresh your memory. You've already seen this. An exponential is different than the other ones because it has many parent functions. All these other ones have exactly one parent function. And if we look at an exponential, its basic form is y equals b to the x, where b is a number and the variable is the exponent. So these are both considered kind of parent functions. So I just want to let you know like that information. And our graph is going to look like this. So we're just going to delve deeper into an exponential today. So let's go through some of the notes. Like I said, the parent function would be y equals, and I'll leave a space here, b to the x. That is the parent function. But it can also have an a. Now that a right here is going to do some of the same things. It is going to do the same things that our a did with quadratics. So we're going to see how that works. A is a non-zero constant. B is greater than 0, but not equal to 1. Okay, so that means it's everything greater than 0, but 1 is excluded. B will never be 1, and you'll see why in just a bit. Okay, because think about it. If I took the basic equation y equals b to the x, that would be, if I had a 1 in there, y equals 1 to the x. No matter what x is, it's still going to be 1. Okay, so with an exponential function, your b is never going to be equal to 1. It can be equal to anything but 1 that is greater than 0. It's kind of unique. X is a real number. Okay, and remember with real numbers, what we're talking about there is that means they can be fractions, they can be decimals. So a real number is whole numbers. Let's just write this down. That's whole numbers. That's fractions. It's decimals. And because it's a real number, it could actually be non-repeating decimals. Okay, so it can pretty much be anything. The parent function in its simplest form would be y to the bx, and we've already talked about that. That's y to the bx. A lot of times what we're going to use is y to the 2x or y to the 3x, y to the 1/2, but y equals 1/2 to the x is also a fairly common one we're going to use. We're just going to explore some. So now we're going to plug in numbers. Feel free to have your calculator out because we're going to use it for lots of different things. So now let's just plug it in. So this is 2 to the negative 3. Okay, so you can plug that in. What's going to happen? And remember, negative exponents, 2 to the 3rd. So that's going to be 1 over 8. Okay, 2 to the negative 2 is 1/4. 2 to the negative 1 is 1/2. 2 to the 0, well, what is anything to the 0 power? 1, exactly. 2 to the 1st, 2 to the 2nd, 2 to the 3rd. Okay, let's plot those points. So we have negative 3. Oh my gosh, this graph is so small. So negative 3 and 1/8. Oh wow, talk about small. Okay, right, we're just going to put it right there. And then negative 2 and 1/4. And it barely is hitting up. Okay, and then 0, 1. Then we go 1 and 2, 2 and 4, 3 and 8. I believe that's there. Okay, now that's what our graph is looking like. We already saw the parent function earlier. Hopefully you can see those points. Okay, so I just plotted those. But before we go any further, I'd like you to take out your calculator, and we're going to add some numbers down here. We're going to keep going smaller, so we actually probably should put them up here. And I want us to go extreme. Let's jump out to negative 6. What happens at negative 6? So 2 to the negative 6, we're just going to plug that in to our calculator. So if you have forgotten where an exponent key is, it's this caret key right here. So we're going to put in 2 caret negative 6, and look what our value turns out to be, 1/64. just to find out, let's look at that as a decimal. Look at that, 0.015625. That's pretty darn tiny. Okay, so that's 1/64th, which is going to be 0.0156 blah, 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 blah. Okay, so that's pretty tiny. So that's at -6. We're pretty tiny. It's like, how much closer can we get? Well, let's see. Let's go really extreme. Let's take like -20. 2 to the -20th. What happens? Surely it's going to get like, well, let's see. Y equals, no, 2 to the -20. And I put in a decimal, so let's try that again. 2 to the -20. Wow! Look at how small that is. So I want you to think about that. Okay? Now, go really extreme. Take a negative number, because notice if I had put in numbers, it's going to keep going up and up and up. And exponential functions, you're going to see in this unit, you've seen this year. These last 2 years, guess what a COVID has been an exponential function when we talked about people getting it, especially right at the beginning. It shot way up. And so you've been listening and hearing about exponential functions when they talk about the number of cases of COVID. So we know this is going to shoot up quickly. But what is it going to do down at this end? So I want you to put in a big, I'm going to put in -100. Okay, I'm running out of space, so I'm going to put that up here. Okay, so 2 to the -100. What does that give me? Okay, so this is scientific notation. This is scientific notation. I have 7.88, and then see how it says times 10 to the -31. What that means, just to refresh your memory on scientific notation, is that means that there are, I would move this once here, and then I would have 30 zeros out here before I got to the decimal point. This is 30 zeros. So if I wrote this out, this would be 7, 8, we're going to just round it to 9 right there. And then there would be 30 zeros right here before it got to the decimal point. Think how tiny that number is. It is just so tiny we can't even write it. It's just impossible to write it up. There are 30 zeros here. We move the decimal point one place, and so we have 30 zeros. That's scientific notation. So what that is telling us is this keeps on getting closer and closer and closer to 0, but does it ever cross it? Does it ever cross it? So 2 to any power, is there anything we could put in for x to make it go to 0? We've done -100 and it didn't go to 0. And there's a reason for that. Okay? And that reason, I know I'm totally out of order on this, but we've got to know this information. So right up here, I want you to write this word right here. Asymptote. That is pronounced asymptote. Asymptote. The P is silent, so an asymptote. What an asymptote is the graph gets closer and closer to this line, but never crosses it. That is an asymptote. Okay? And the asymptote in this situation is the x-axis. So right here, this line right here, this graph will never touch. It will get closer and closer, but it will never touch it. It comes right up to it. So here's the graph of this line. And I wanted to talk about an asymptote because we're going to be doing these over and over again. It will get closer and closer, but it will never touch it. It never crosses that because it's an asymptote. And also because it can't. You can't get it to go to 0 no matter what you do. Okay? So let's look at our graph, and let's look at domain and range now. So domain, is there any restriction on my x value? Nope. So it goes from -infinity to infinity. But look at our range. That asymptote, right here, that asymptote, which happens to be the x-axis, and it will be for all of today's, that asymptote prevents it from going past that. So my y values go from 0 on up, but can't be 0. So that's even a parenthesis, 0 to infinity, because it goes from here on up. Okay? So that's when we have 2 as b. Let's look at what happens when we have a fraction. Okay, so now we're going to plug in a fraction. So this is going to be 1/2 to the -3rd. Okay, remember that negative is going to flip it, so that becomes 2 to the 3rd, which is 8. Okay, so now we have 1/2 to the negative 2. That becomes 2 to the second, because that negative exponent flips it. So we get 4. 1/2. You see the pattern that's happening? Okay, now we have 1/2 to the 0. That's equal to 1. And that's something you're going to see with all of these. If there's going to be a point, whenever 0, it's going to be a 1. And that's one of the reasons you know it's an exponential. Unless, of course, some other stuff we're going to look at tomorrow. Okay, but that point's going to be in the parent function. And this is also technically a parent function also. Okay, so here we go. Keep going. So 1/2 to the first. Okay, 1/2 to the second. You can see again a pattern. 1/2 to the third. Okay, and this is going to have that same asymptote. It's never going to cross it. When I have a parent function like this, meaning that this is a number, b is a number, then it's going to be that my asymptote is always the x-axis. That's my asymptote. Okay, so I want you to be clear on that. That's going to be your asymptote on a parent function. We'll look at some more stuff tomorrow. Okay, in the next lesson. So now we're going to plot this. So negative 3 and 8. Oh my gosh, this is tiny. Negative 3 and 8. Negative 2 and 4. Negative 1 and 2. There's that 0, 1 that we're always going to have. And then we go 1/2 and 1/4 and 1/8. And it just keeps getting closer and closer and closer to 0. But again, we'll never cross it because there's an asymptote. Oops. Okay, and just keeps getting closer and closer, but it will never, ever cross it. Never cross the asymptote. Okay, domain and range on this one, pretty much the same thing we just talked about. Any restriction on my x? Well, obviously not. Any restriction on my y? Well, of course, it has to be from here on up. It has to go from 0, but 0 is not included, so it's a parentheses, to infinity. Okay, good. Now this next part will sound familiar because we just did it with quadratics. A also affects the graph. Let's see the difference between a positive and negative a in the two examples above. The a was positive. Okay, how are they different than the two examples below? Let's take a guess. Let's take a guess what's going to happen. Okay, so when a is negative, it's going to, when we have this, think about our parabolas. Think about our parabolas for a second. So if I have y equals x squared, my parabola looked like this. There's my parent function, right? But when I have y equals negative x squared, it did this. Now we always said that this one opened up and this one opened down, which is true. But what's really happening, it's reflecting over this axis. It's reflecting over. So it's a reflection. So how is it different when a is negative? Well, guess what's going to happen? Same thing. It's going to reflect. But let's just show that. Okay, so I have a negative, and then I'm going to take 2 to the third power, so that's going to be a negative 8. Negative, 2 to the, oops. That's a negative, sorry. So this becomes negative 1 over 2 to the third, which is 1/8. Wrote too big there. Okay, so that's 1/8. This is 2 to the negative 2, so that's going to be negative 1/4. Okay, and then we have negative, still out in front, 2 to the negative 1, makes it flip, so it's negative 1/2, because it flips this down to the bottom. Then we plug in 0, guess what happens? It's 1. Okay, but now it has a negative out in front. So we have negative 2 to the first power, negative 2 to the second power, negative 2 to the third power. Okay, and when we plot this, look what happens. Negative 3 goes to 1/8, and then 1/4, and then 1/2, and then negative 1, and it's 1, it's negative 2. So I want you to compare, and then when it's 2, it's negative 4, and 3 is negative 8. Okay? Now, the asymptote is still going to be the x-axis. Still going to be the x-axis. It's never going to cross that. So if you compare, so let's draw this in, and then we're going to get closer and closer, but we never hit it. Okay? Look at this one. Didn't we just reflect it? If this were a mirror, I reflect it over the top. Here's my axis. Also my asymptote, I'm going to reflect it over that. So a negative just reflects it. This is a reflection. The negative reflects, and I know some of you encountered that on the NWA test, you might on the EOC, reflects over the asymptote. And I said it that way because of what's coming in our next lesson. Okay? So look at this one. Look at this one. What do you think is going to happen? It's just going to reflect over. It's just going to reflect. So I could actually use these points and know that it's just going to, everything's going to go negative, right? Isn't everything just going to go negative? Can't I just take all these? So 3 is going to be negative 8. Negative 2 is going to be negative 4. And what I'm doing is I'm just up here going, okay, negative 1 is going to be negative 2. It's going to be negative 1 and negative 1/2, negative 1/4, and negative 1/8. Oh, I'll come back to domain and range. Sorry about that. Okay, I got too excited. So again, my asymptote on a parent function is going to be my x-axis. So this is just a reflection, but we're going to have 3 and negative 8. Negative 2 is negative 4. Okay, plot those points. And it gets closer and closer and closer. So it's going to come along and just gets closer and closer to that asymptote, which happens to be the x-axis right now. Okay, so let's hit our domain and range. So our domain here, any restrictions on x? Nope. Not too exciting right there. Our range, though, from now goes from 0 to negative infinity, right? So it's going from 0 to negative infinity. But when we write it in interval notation, remember it has to go smallest to largest, so negative infinity to 0. And you can see this is going to be the same thing. Domain, no restrictions. Why there is a restriction? That asymptote is a restriction. So negative infinity, so it goes from negative infinity up to 0, but will not cross it. Okay, and that same brain trick we've talked about, if it's positive, if think smiles, then A is positive. Okay, this is kind of a crooked smile as far as I'm concerned. So crooked frown, crooked smile, crooked frown. Okay, and this is going to be negative. Okay, good. Let's look at homework. Evaluate each exponential function for the given domain. So that just means you're going to plug those in and find it. Okay, find out what the value is. Can you use your calculator? Evaluate the exponential functions by completing the table, graph the function, determine the domain and the range. Okay. Oh, what do you think that's going to do? It's going to make it go up faster, isn't it? That's going to be a stretch, since we just talked about those. Let's look on the back. Okay, this is just giving you some different values to plug in and see what happens. Okay, so then state the domain and the range, and they just give you a little table. So you're still going to use that parent function. This parent function is what it's going to look like. It's just going to change the values. Okay, go. So that is all the notes for today. Check on Schoology to see what your assignment is, if in doubt, and your teacher will probably tell you too. So there we go. Hey, and if you have any questions, you know where to find us. Thank you very much.